Now let's consider a real-life situation that can be modeled by a quadratic equation. The path of a projectile. An object thrown or fired straight up at an initial speed of v0 feet per second will reach a height of h feet after t seconds, where h and t are related by the formula h equals negative 16t squared plus v0 t. Now the v0 just means velocity. And that negative 16 is just a coefficient for gravity in feet per second. So there's one for feet and there's one for meters. This is for feet. All right, so we have our constant, our coefficient for gravity at negative 16, and then v naught is just whatever the velocity of our object is. And velocity can be positive or negative. Suppose that a bullet is shot straight upward with initial speed of 800 feet per second. Now velocity and speed aren't exactly the same thing. Speed is the absolute value of velocity. But this case, because it's upward, it will be a positive, and the speed and the velocity are exactly the same. So just a little note. Speed is the absolute value of velocity. But since it's 800 feet, it's a positive value because it's going to be upward. So speed, in this case, speed and velocity will be interchangeable. All right, so that right there is our v naught. All right, so when does the bullet, so let's actually write our equation, and then we'll answer A. All right, so our equation is h equals negative 16t squared plus 800t. When does the bullet fall back to the ground level? All right, so the ground is at 0 feet. So now we're just going to set our equation equal to 0. So we have 0 equals, so our height's going to be 0. Maybe I should put h equals 0 feet. All right, so 0 equals negative 16 t squared plus 800t. We can factor out a common factor. This is an easy solve. All right, so they're both divisible by negative 16t. And so that's negative 16t squared divided by negative 16t is t. 800t divided by negative 16t is going to be 50, right? Because 80 divided by 16 is 5. 800 divided by 16 is 50. And, oh, excuse me, that's going to be a negative there. My plus sign is looking a little funky. There. And so when we factor out negative 16, that will become negative. So we have two solutions here. When negative 16t equals 0, so t is 0, this is when the bullet leaves the ground, right? And no time has gone by. T minus 50 equals 0. 50, and we should put a unit of measure there, seconds. So 50 seconds, the bullet returns to the ground. I'll just put bullet returns. I'm trying to stretch here and still be able to talk into the microphone. All right, so now let's look at B. When does it reach a height of 6,400 feet? All right, so now H is 6,400 feet. So now let's just set our equation equal to 6,400. So I'll do B right here. So we have 6,400 equals negative 16t squared plus 800t. To solve this, we need to move that coefficient over, because I think we're going to be able to factor it. We at least have a common factor here. So 0 equals negative 16t squared plus 800t minus 6400. And they're all divisible by negative 16. So that's going to be t squared. 800 divided by negative 16, of course, is 50. And 64 divided by 16 would be 4. So this is going to be 400, 2 zeros. And let's see, multiplies to give us 400, adds to give us negative, plus. And this is a minus. Sorry, we're dividing by negative. This one's a minus, that one's a, oops. Now I put the eraser in the wrong spot. This one is a minus t, and that's a plus 400, right, because we're dividing by negative. So multiplies to give us positive 400, adds to give us a negative 50. Well, that's going to be negative 40 and negative 10. All right, and so we have 0 equals negative 16. Actually, we can divide both sides by negative 16, and that will give us 0 equals t squared minus 50t plus 400. All right, so we'll replace the negative 50t with a negative 40t and a negative 10t. And the first two are a group, and the second two are a group. And we can, out of the first set, we can factor out a t. So we have 0 equals t, and that would be t minus 40. Out of the second set, we can factor out a 10, a negative 10. That's the second time I put that in the wrong spot. Yeah, there, that negative looks much better. So plus negative 10 and t minus 40. So we're pulling out a greatest common factor. Notice we have repeating t minus 40. So t minus 40 is one factor. The leftover t minus 10 is the other factor. And now we have two solutions here. I'm going to solve over here, and I'll do a drawing. Excuse me, I'll solve over here, and I'll do a drawing over there. So we have t minus 40 equals 0. T is 40 seconds. And if t minus 10 equals 0, t equals 10 seconds. And we have two solutions here. You might wonder what's going on. Well, our bullet goes up and our bullet goes down. And imagine that this is a graph here. We'll put them on the coordinate plane. Our y value here, and I'll put it right, I guess here, is 6,400 feet. And that's going to occur, let's say it occurs, I guess here, oops, and here, not exactly going where I'm at, putting those dots. All right, and this would be at 10 seconds, and this would be, let's move that over, and this one would be at 40 seconds. All right, so it happens twice because it goes up, it goes through, so it goes through the 6,400 feet. Right, it's going to it keeps on going a little higher, and then it comes back down to the 6,400 feet. Now, how do we know it keeps going higher? Right, because that's not the vertex, because it hit that value, that 6,400, twice. Right, so we're going to find out what the vertex is in D. Let's do C. When does it reach a height of 2 miles? And I have no space, but I have space over here. I think I said these are in your notes. If I didn't, these are in your notes. So C, when does it reach a height of 2 miles? All right, so Now be careful, don't set this equal to 2, right? We're dealing with feet, right? So we need to change 2 miles to feet. Well, 2 miles, well, 1 mile equals 5,280 feet. So 2 miles equals 10,560 feet, right? So we've gotten, so I'll do C here. We have 10,560 equals negative 16t squared plus 800t. So we can move that constant over. So we have 0 equals negative 16t squared plus 800t minus 10,560. And I don't know if this is factorable with these huge numbers, but I think they might all be divisible by, oh, somebody used my calculator. It's not here. Let's see if I have another one. Hopefully this one works. I think they're all divisible by 16. Nope, this one has dead batteries. Fortunately, I have one not too far away. And this is not a good one. There we go. It's kind of like dark. It's a really old calculator. But it will do for this. All right, so we know what 800 divided by 16 is, but how about 10,560? Of course, I could have brought the calculator up from the computer. Divided by 16. Yes, they're all divisible by 16. So we can at least divide everything by 16. 0 equals negative 16t squared minus 50t plus 660. All right, so we can divide by negative 16, so that gives us t squared minus 50t plus 660. And I am very certain that there's nothing that multiplies to give us 660 and adds to give us 50, right? Just nothing. All right, so let's use completing the square. This one's an easy one with completing the square. So we will subtract 660 from both sides. So we have negative 660 equals t squared minus 50t. And then, if you don't mind, I'm going to add the magic number right at the same spot. We saved a spot for it. So plus, our magic number is going to be b, which is negative 50 divided by 2 squared. And we'll add that to both sides. Negative 50 divided by 2 squared. There we go. Orientation maybe a tad off here. And we have negative 660 plus, right? And so that's going to be 25 squared. That's 625 equals t squared minus 50t plus 625. And I see that we have a little bit of a problem. Because if we simplify this, we've got negative 35 equals t squared minus 50t plus 625. Now we can certainly factor the t squared minus 60t plus 625, 50t minus 50t plus 625, that would be t minus 25 all squared. However, if we take a square root of both sides, what's going to happen? Here, I'll extend the board so that we can just make sure everyone understands the problem that we have here. So here on this side, this is t minus 25 all squared. On the other side, we have negative 35. We go to take a square root of both sides, and right? This is going to be plus or minus I square roots of 35. 35 will simplify, but it's an I. We have an imaginary solution here. So what does that mean in terms of this word problem? Let's think about how the bullet was. So it's, how far is that bullet going to go? Is it going to go 2 miles? No. The bullet never reaches 2 miles. Since there is no so there's no, and we know that because there's no real solution. So since there's no real solution, I'd even bother to move the 25 over. If you like, the final solution is t equals 25 plus or minus I square roots of 35, but who cares? Because the bullet never reaches 2 miles. It's a complex number. It's an imaginary number. So there is no, when does it reach a height of 2 miles? Never. That's when it reaches 2 miles. Let's answer the last question. What's the highest point the bullet reaches? And we're going to find it's not 2 miles. All right, so we have, to find that, we're finding the vertex. All right, the vertex is the top part of our parabola. There's a formula when it's in standard form. The x-coordinate is called h. And that's found by taking negative b dividing by 2a. And to find the y-coordinate, you can plug it back in. There is another formula. So we can either substitute it back or we can plug it back in. And it's the formula, if it's not pretty, is negative, let's see if I remember, b squared minus 4ac, I like quadratic formula, all divided by 4a. Yes. All right, so we can use that because I don't think it's going to be a pretty number. All right, so our x-coordinate, our h, so b was our formula or equation, which is not up here, was h equals negative 16t squared plus 800t. So a is negative 16 and b is 800. So this would be, h would be negative, so negative 16, so positive, divided by, not 16, b, 800. 800 divided by, and it'd be negative, but it's going to cancel out. And then we would have 2 times negative 16. So negative b divided by 2a. So the negatives will cancel out, and this ends up being 2.5. So maybe not the nicest number to plug back in. I don't know. And we could just use our formula there. So we have negative, and that would be, I don't think it's going to make much of a difference, is it? 800 squared minus 4, well, this part's easy. 4 times a, which is negative 16, but there's no constant term, so that's 0. So actually, it might be a lot easier. And that's all divided by 4a, so that's going to be 4 times negative 16. So k is negative 6,400 divided by negative 64. Wait, no, sorry. I looked at that and go, wait a minute. Negative 64 and then 4 zeros, right? If we're squaring something with 2 zeros, when we square it, we'll have 4 zeros. Divided by, well, this was it's nice and easy using the formula. So this would be 64. And so our final height is, oh, and that was negative. Those negatives will cancel out. Our final height is 10,000 feet. And we can see our problem. Let's just get rid of the negatives. All right, in that last, so we can see our problem from the last question there. So k is equal to 10,000 feet. That's our highest point. So the highest point that the bullet reaches is 10,000 feet. So if its highest point is 10,000 feet, there's no way you could go 10,560 feet. All right, so here's some applications of quadratic formula. Thanks for watching, and bye for now.